Morning everyone. Today I would like to introduce you to the Snapdragon 8 Gen 3, which is Qualcomm flagship mobile platform. Officially launched on 24 October 2023, it is specially designed to deliver premium performance and advanced AI capabilities for high-end smartphones. One of the standout features of the processor is support for on-device generative AI models. This means that powerful tasks such as image generation, content creation, and even real-time voice and language processing can be done directly on the device without needing an internet connection. The Snapdragon Gen 3 is built using 4nm process technology by TSMC, making it more powerful and energy efficient. This processor uses the traditional fetch-execute-decode cycle, which is the basic process used by all CPUs to carry out instructions step by step. It features an octa-core CPU with the following configuration: 1 prime-core Cortex-X for up to 3.3 GHz, 5 performance cores Cortex-A720 up to 3.2 GHz, 2 efficiency cores Cortex-A520 up to 2.3 GHz. This 1 plus 5 plus 2 structure provides a perfect balance between speed, multitasking, and battery efficiency, allowing smartphones to handle everything from heavy gaming to background tasks smoothly. In the next part of our presentation, we will explain how the fetch-decode-execute cycle works inside this processor to complete every instruction.
The diagram 1.0 shown is the architecture of Snapdragon 8 Gen 3. Based on a 4nm TSMC N4P process technology, it utilizes a 1 plus 5 plus 2 core configuration, meaning it has 1 prime core, 5 performance cores, 2 efficiency cores. This combination allows it to balance performance and power consumption for a wide range of tasks. First, we have the prime core Cortex-X4. The prime core is a single Cortex-X4 built for peak performance. It has a 64 KB instruction sketch with advanced branch prediction and a 10-wide decode unit, making it extremely fast at preparing instructions. Its execution unit is very powerful with a reorder buffer over 300 entries and 6 integer plus 4 floating point pipes. For memory, it has a 64 KB data cache and 3 load 12 store ports, making data access fast and efficient. Next, we have the performance core, 5-time Cortex-A720. Cortex-A720 cores handling balance tasks like multitasking and sustained workloads. Each has a 64 KB instruction and data cache, a 6-wide decode unit, and around 200 entries in the reorder buffer. They are slightly less powerful than the prime core, with 4 integer and 2 floating point pipelines, but are more energy efficient. And lastly, the efficiency cores, 2-time Cortex-A520. The 2 Cortex-A520 cores are built for power efficiency. They have a 5-wide decode, a reorder buffer around 178 entries, and use fewer pipelines, just 3 integer and 1 floating point. These are used for lightweight or background battery life tasks and help extend battery life. Next are the cache and memory hierarchy. Each core has private L1 cache, 64 KB for instructions and data. The prime core has 2 MB of private L2 cache, while the performance and efficiency share 0.3 MB L2 per core. All cores share an 8 MB L3 cache, allowing fast access to shared data. The system memory empty uses LPDDR5X at 4800, providing 61.2 GB bandwidth cores. Lastly, accelerators and input and output. The chip also includes powerful accelerators. The Adreno 750 GPU supports Vulkan 1.3 and hardware ray tracing. The Hexagon NPU is 60% faster than before, helping with AI tasks like voice recognition or image enhancement. The Spectra ISP can handle 200 MP photos and 4K HDR video, and the X75 modem supports 5G speeds up to 10 Gbps. Before we dive in, the fetch-decode-execute cycle is how a processor handles instructions. Fetch brings the instruction from memory, decode translates it into signals, and execute runs it using arithmetic or memory units.
Let's talk about fetch stage. First, in the first stage, the process takes place in the instruction fetch unit IFU. This unit will fetch the next instruction from the 64 KB L1 instruction cache. If the sort instruction is not found in the L1 cache, it will continue the search to the L2 cache, then L3, and finally to RAM. This unit also uses branch prediction to predict the direction of instructions such as loops or jumps, so that processing can continue without interruption. During the first stage of the cycle, the program counter holds the address of the next instruction to be fetched from memory. The address of the instruction or data to be fetched is copied into the memory address register. Let's talk about decode stage. The cortex A720 is 6 wide and the A520 is 5 wide. Interestingly, the Cortex-X4 also has a micro-op cache that allows decode instruction to be reused without having to be reprocessed, thus saving processing time and energy. During the execute stage of the cycle, the CPU will carry out the instruction that was fetched. Some examples that would take place at this stage are: first, performing a calculation; second, storing a result or data back in main memory (RAM); and lastly, going to main memory to fetch data from a different location.
Now, I will explain about what happened in decode unit Snapdragon 8 Gen 3. In this stage, the instruction translated into something the processor can execute. This is where the decode unit does its jobs. For example, convert binary instruction from fetch stage into micro operation. These micro operations are small, low-level steps that can be executed by the CPU execution. How it works in Snapdragon 8 Gen 3. So, in Snapdragon 8 Gen 3, they have 4 types, which is Cortex-4X, Cortex A720, Cortex A520, and micro-op cache. For Cortex-X4, the decode width is 10 wide decode, which is can decode 10 instructions per cycle, which is very fast and efficient.
So now I will explain about execute. So what is execute? Execute is do the instruction, actually draw the button, play the sound, and something else. First of all, I will explain about the prime core or Cortex-X4, or we call as boss core. With 6 integer and 4 floating-point pipelines, it handles both logic and math-heavy tasks. It uses a ROB, reorder buffer, with over 300 entries, letting it run instruction out of order for speed. Example, while the character swings a sword in intensive animation, it simultaneously calculates damage, sound, and visual effect. Next, about performance core, Cortex A720, or we call as the office workers, 4 integers and 2 floating-point pipeline with 200 ROB entries. Example, while showing a map, it calculates your position in math, update routes in logic, and manage touch input in real-time response. Lastly, for efficiency core, Cortex A520, or we call as the interns, with 3 integer and 1 floating-point pipelines, 128 ROB entries. For example, execute play next song, check Wi-Fi signal, or keep time ticking tasks.
Next, I will explain what happened in memory stage. In memory stage, there's have load or store unit and known as the LSU in the Snapdragon 8 Gen 3 processor. The LSU is responsible for loading data from memory and storing data back into memory during program execution. It works closely with the cache system to make sure the processor gets the data it needs quickly. Each CPU core in Snapdragon 8 Gen 3 has a private 64 KB LI data cache. This is the first and the fastest place the processor checks when it needs data, because it's very close to the core. Accessing data from LI data cache only takes a few clock cycles. The Cortex-X4 core has more advanced memory access features. It includes 3 load ports and 2 store ports. This means it can read 3 values and write 2 values at the same time. This improving performance in tasks like gaming, AI, and content creation. If the required data is not found in the LI data cache, The processor will look for it in the next level of the memory hierarchy. For example, first it checks the L2 cache, which is about 2 to 3 MB. If it's not there, it checks the L3 cache, which is 8 MB and shared across all cores. If data is still missing, it finally accesses the main RAM, which is LPPDDR5X. Thank you.
In summary, across all cores, the fetch-decode-execute cycle does the same steps: grabbing, translating, and executing instructions, but the scale differs. The prime core does it the fastest and widest. The performance cores balance speed and efficiency. The efficiency cores do it slowly but with minimal energy. This core diversity allows Snapdragon 8 Gen 3 to switch between them depending on what you are doing, whether it's gaming, browsing, or just checking messages.